Today we're going to look at SOHCAHTOA. Yes, reviewing SOHCAHTOA from geometry. Guys, SOHCAHTOA is your helpful mnemonic for remembering those definitions of our trigonometric functions, sine, cosine, and tangent. And it's used to calculate the ratios from a right triangle to find either a side length or an angle measure. Guys, we're going to keep this super simple, but I do want to remind you of sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, and that's where we get that so, ka, and toa. So let's review that a little bit here. Find the missing side of the triangle number 1. In that triangle, they've given us an angle measurement of 33 degrees. Now let's look around our triangle. From that angle 33 that they gave us, this top left side is going to be my adjacent because it is adjacent to that angle measurement that they gave us. Where we see the 3 over here, that's the opposite side because it is opposite of the angle 33 they gave us. And then always directly across from your right angle has your hypotenuse. So as we look at this angle 33, we've been given 3 and we've been given x, the opposite and the hypotenuse. So we can use sine 33 degrees and have our opposite value 3 over hypotenuse x to help us finish solving that problem. That's all we're doing here, just reviewing where we get sine, cosine, tangent using SOHCAHTOA. Number 2, they've given us 24 degrees here in this angle. Across from that, that's your opposite angle. Where we have x here is the adjacent because it's attached and adjacent to that 24 degree measure. And directly across from the right angle is where you have your hypotenuse. Now, from our 24, we've been given a 5 and an x. We've been given a hypotenuse and an adjacent. So we can use cosine 24 degrees, putting our adjacent on top x over hypotenuse 5. Moving on, number 3, we have a 47 degree angle given. This would be my opposite side. 25 is the adjacent side, and x represents the hypotenuse. We've been given 25 and x, the adjacent and the hypotenuse, so we are again going to use cosine 47 degrees with that adjacent 25 over hypotenuse x, and we would use that to solve. So just reviewing where our adjacent, opposite, hypotenuse sides are and how to use SOHCAHTOA. Let's put it into action below. On our notes here, I have that trig value, sine, cosine, tangent, can be found without a triangle and a given angle if you know your Pythagorean theorem or Pythagorean triple. So let me remind you your Pythagorean theorem, a squared plus b squared equals c squared. That tells me the lengths of the sides of my right triangle where a and b are a side of my right triangle and c is always the hypotenuse. If I take those side lengths, I square them, add them together, I can find that it is equal to the hypotenuse squared. So you can use Pythagorean theorem if you want to, or Pythagorean triples are common measurements that always work in the Pythagorean theorem, like 3, 4, 5 is probably the most common. If you have a side length of 3, a side length of 4, the hypotenuse will be 5 every time because 3 squared plus 4 squared is 25 or 5 squared. And any multiples of that. So 6, 8, 10, 9, 12, 15, any multiples of 3, 4, 5 also work. I've also got several others here listed for you. Now, Delta Math uses Pythagorean triples very often. 5, 12, 13, 20, 21, 29, 7, 24, 25, and so on and so forth. So you can use that as your reference sheet there of common Pythagorean triples. There are more out there in the world, but these are the most common that, like I said, Delta Math will use. We also need to know where our trig functions are positive or negative. So I'm talking back to 1, knowing where your quadrants are, 1, 2, 3, and 4 in that order. And we're talking about all students take classes where they are positive, ASTC. All of our trig functions are positive in the first quadrant. Sine is positive in the second quadrant, tangent is positive in third, and cosine is positive in the fourth. So remembering that helps us answer these questions. And then, of course, SOHCAHTOA, sine over opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So let's put this into action. I'm going to look at number 4 here. Given that sine theta is negative 4/5 and that angle theta terminates in the fourth quadrant, then what is the value of cosine theta? For these problems, I always sketch the same right triangle every time. So I'm going to get it set up. I'm always going to use that bottom right corner as my given angle theta. We don't really know what theta is right now, but we do know that sine theta was equal to -4/5. I'm going to finish labeling here. So if my angle is in the bottom right corner, I'm going to have opposite. This is my adjacent, and this is my hypotenuse. So if they've given me that sine theta is -4/5, remember sine is equal to opposite over hypotenuse. So I'm going to use that to label. My opposite is a 4. Don't worry about the negative at this time. And my hypotenuse is a 5. I need to fill it in with my missing adjacent side. So I'm thinking back to my Pythagorean triples, that 3, 4, 5. You could also do Pythagorean theorem and solve and see that we are missing the adjacent side of 3. Now the question was, what is cosine? So cosine is equal to adjacent over hypotenuse. So I'm going to take my adjacent 3 that we just found over my hypotenuse 5. The last thing I need to consider is they told me we were in quadrant 4. So this goes back to knowing ASTC, where my functions are positive. In the fourth quadrant, cosine is positive, the rest would be negative. We are looking for cosine. So I'm just going to leave that positive 3/5 final answer. Cosine theta is 3/5. Let's try it again. Number 5, I'm going to sketch the same right triangle with my given angle being in the right corner. We've got opposite, here's adjacent, and this is my hypotenuse. They've given me the information that tangent theta is equal to 5/12, and that angle theta terminates in the third quadrant. Then what is the value of sine theta? Tangent is equal to opposite over adjacent. So I'm going to go over here and label my opposite 5. My adjacent is 12. And looking at my Pythagorean triples, 5, 12, 13. Now remember, your hypotenuse is always your longer side, so I am missing 13 for my hypotenuse here. Back to our problem, we are looking for sine theta. Sine is opposite over hypotenuse. My opposite was 5. That hypotenuse we just found was 13. Now, last thing you need to consider, what quadrant are we in? Third quadrant. In the third quadrant, all students take. T stands for tangent, is the only one that's positive. So that means if I'm looking for sine theta, it's going to be -5/13. Be sure you add in that negative because in the third quadrant, sine is negative. Number 6, given that cosine theta is 7/25 and angle theta terminates in quadrant 1, what is the value of tangent? Sketching that same right triangle. Here's my opposite side, adjacent side, and hypotenuse. They've given us that cosine theta is equal to 7/25. Cosine is equal to adjacent over hypotenuse. My adjacent value is 7. My hypotenuse is 25. Thinking of my Pythagorean triples, we've got a 7, 24, 25. So I'm missing that 24 for my opposite side here. In our problem, we are looking for tangent. Tangent is opposite over adjacent. So opposite 24 that we just found over adjacent is 7. Now the last thing you need to consider is where are we? We are in the first quadrant. In the first quadrant, all of our trig functions are positive. So while we're looking for tangent in the first quadrant, it is positive 24/7, final answer. And last one, number 7, given that sine theta is 8/17 and angle theta terminates in quadrant 2, what is the value of cosine theta? Sketching my same right triangle just so I can get my bearings. Here's opposite, adjacent, and hypotenuse. They gave us that sine theta is 8/17. Sine is opposite over hypotenuse. So going to my triangle, 8 is opposite, hypotenuse is 17. Thinking about my Pythagorean triples, we've got a Pythagorean triple that is 8, 15, 17, missing that 15 for our adjacent side. Back in our problem, we were looking for cosine theta. Cosine is adjacent over hypotenuse. Our adjacent 15 that we just found over hypotenuse 17. And lastly, consider where are we? We are in quadrant 2. All students in the second quadrant, S, all students stands for sine is positive, the rest are negative. So we were looking for cosine. My answer for cosine in the second quadrant should be a negative value, 15 over 17, final answer. And that's our lesson on SOHCAHTOA. Yes, a review from geometry, and then pulling in a little bit that we've been talking about with our unit circle. All students take classes, remembering where our trig functions are positive. Also, I've got a list here of your Pythagorean triples to help you answer those questions. I do recommend sketching your right triangle, getting all of your values in the correct place, keeping straight your sine, cosine, and tangent ratios there. Watch out, of course, double check before you submit an answer. What quadrant are you in? Make sure if it's supposed to be negative, you tag on a negative on your value based on the quadrant that you've been told your theta is in. So let me know if you have questions, guys. Good luck, and I'll see you in class.